Hi guys, welcome. Today is day 31. We're looking at lesson 79. So we got 79 and 80, and that's it as far as new lessons for the semester, and then we'll review and take the test and all of that. But we are nearing the end, so that is exciting, at least for this semester. So in lesson 79, if you guys want to flip over there, we are looking at transforming formulas. So again, we know what a formula is. Area equals base times height. Distance equals rate times time. And whatever our formula is, but we can manipulate these or move these around and write them in several different ways. So distance equals rate times time. So distance equals rate times time, which we know that. Going 10 miles an hour for an hour, the distance I've gone is 10 miles. So distance equals rate times time. I can also write in terms of r. If I divide both sides by t, I get t out of there, and I get r equals distance divided by time. Or I could have multiplied both sides by t, and then divide by r, and time equals distance divided by rate. So again, we're not changing a formula, we're just writing it different ways. Like if an area formula, if we're given the area and the base, we want to find the height, we can plug in area equals base times height, the area and the base, divide both sides by the base to work it over so the height is by itself, and then calculate it. Again, just like we do with numbers when we're trying to isolate an unknown, we can do it with other unknowns as well. The same properties still apply. We can, if we multiply both sides by something, or divide by something, or add something, we can still keep it equal. So we can manipulate these formulas if we need to. Again, that's just showing all of that right there. So the same formula, but we can write it in several different ways. In this example, if we have W equals x plus b, and we want to solve it for x, well, x plus b, I'm going to get rid of this positive b, we're adding, so I'm going to subtract. So x plus b minus b is just x plus 0, or just x by itself, and then if I did it to the right side, I have to do it to the left, so minus b, so we end up with x minus b. If we have circumference equals pi times d, we measure the circumference of a basketball, then we calculate the diameter using the formula circumference equals pi times the diameter. Transform the formula to solve for d. Circumference equals pi times the diameter. We know that. We want to get it in terms of just the diameter. If we know the circumference, pi is a constant. We want to find the diameter. We can't really just, I guess we could, but it's going to deflate and not be perfect, but we can't cut a basketball in half and measure across. We can measure the circumference, and then we can divide by pi. Pi divided by pi is just 1. This gets d by itself, so d, the diameter in this case, equals circumference divided by pi. And it's actually, if we look again at circumference equals pi times the diameter. If we divide both sides by d, pi is equal to circumference divided by diameter. That's actually how they first started looking into this constant that was always there, this number that, well, if we take, if we measure, even if it's not perfect, it's a circle, if we measure the circumference and the diameter, we divide those, we get this number always. In every circle, there must be some correlation there, and there was. So there's this constant known as pi. So that's way back in ancient times when they were looking to discover these things. That's how they first went about finding pi. They rounded it to 3, then it got a little bit more precise, and since then, computers and stuff have taken off. They've taken out to like 1,000,000 decimal places. So, annual space. We're solving for radius A equals pi r squared, so the area of a circle, and find the radius of a circle with an area of 154 square centimeters. Okay, so we have our circle. And we're given the area already as 154 square centimeters, and we want to find the radius. Well, area, which we know equals pi r squared, and we were told to use 22/7 for pi, so we'll go ahead and do that. And 2/7. Again, if I'm going to divide by this fraction, that's the same as multiplying by the reciprocal. And so 7 times 154 divided by 22 equals 49 square centimeters. Now that's r squared. We want to figure out what r is. So okay, the square root of both sides. The square root of 49 square centimeters is 7 centimeters. And take the square root of centimeter squared is just centimeters. Square root of 49 is 7. Square root of r squared is just r. Our radius 7 centimeters. So again, we're given enough information to find. Usually we want to find the area, and we're given the radius or the diameter, but in this case we're given the area and we're going to find the radius. And just plug it into the formula and then manipulate just like we've done in the past. We work backwards to find r. All right, that practice set we'll do together. This is the only lesson we have for today. We'll see you guys later. One more lesson to go.